Good morning, guys. I'm hoping that I can help you all out with wiring your boats up correctly. RFI and EMI has become a real problem with modern day electronics. They are very, very sensitive to these things. It seems the boat manufacturers have not addressed this like the sound and video industry has. So I'm trying to apply their techniques to the electrical systems in our boat. RFI, radio frequency interference, is an electromagnetic field that can travel even through the voids of space. SONAR is a sound wave created to travel through water to reflect back a signal that ends up on your MFD for your electronics. They are both very critical. There are steps we can take on it to improve it. In this series of videos, we're going to cover wire sizing, how to select the type of wire and the correct size for your boat, resistance and voltage drop, circuit protection, wiring connections and termination, prevention of RFI and EMI, wire shielding, which is very important, tools and techniques, and also how to draw up a plan to get this wiring system correct on it. Every boat is different. Every electronic system is different due to the number of units that you install on the boat. Okay, let's talk about absolute voltages and ground loops for just a bit and a couple of demonstrations. A ground loop is when you have unequal ground level voltages from different sources, especially when you have multiple batteries in a boat. We prefer not to have any ground loop current at all if we can avoid it and get it out of there. Absolute voltage, I think the best explanation is if we drive a ground rod into the earth until it's down to a moisture level, hook your negative cable to it, and hook your positive lead to the negative on the battery. That would show absolute ground level. Now, what I'm getting at is sometimes if you go negative to negative on batteries, you will see some voltage. And I'm going to just show you evidence. You see on the meter, we're showing 0.001, virtually no voltage. Now what we're going to do is hook the other lead up to a trolling motor, battery number 1, ground. Absolute voltage would be 0. You're going to see that's not true though. Okay, now we're seeing what, volt, 1.5, 1.6 volts on the screen. That is the difference in ground level voltage between those two batteries. And you can go from batteries to batteries and see a different level, usually less than 2 volts on it, but there is a difference. There is a potential for current to flow from one battery to the other on it. Also keep in mind, battery electrical electrons actually flow from negative to positive. Most people assume they flow from positive to negative. They do not. This was discovered in about 1955 that Ford Motor Company was right about this and GM was wrong on it, that they flow negative to positive. The reason I stress this is most people concentrate on the positive circuit on it. I'm trying to stress how important the negative side is. It is of equal importance. If you have an electron flow in the negative side, you have the same amount of electron flow on the positive side, always. Ground loops is when you get sources for that current to travel. It might be through your trolling motor, it might be through your electronics, it might be through your battery charger. And do not forget, a battery charger has the potential to create a ground loop even when it's unplugged and not working. So we're going to demonstrate some things here. First, I'm going to turn on the trolling motor on the trolling motor circuit on this boat. And you will see the voltage jumped up substantially on it. That is voltage potential pushing some current from ground to ground, which we would like to eliminate if we can. We might not get it perfect, but by the time we're done with this boat, we hope to get it down lower than it is currently. Now, you'll also notice if I go to a different battery, it changes dramatically. And the reason being that I'm no longer on the negative battery of battery 1. I'm on the negative battery of either 2 or 3, so we're going to either have over 12 volts or we're going to have 24 volts on it. Now I'm going to go back to battery 1 again, connect that to a charger. How much change did we get there, Mark?
You're at a 16.2. I can't see the dot on it. Maybe it's 1.506.
So it's not a big difference over no charger, right?
So right now you're at a 1.52.
So very little change. So that charger is helping avoid ground loops. There's almost no change on it. The big change is when we turn the trolling motor on it.
6.9.
Yeah, somewhere in the charger circuit, there is a path for current. It could be the transducer, it could be a network connection, or it could be improper wiring on it. By the time we're done with this boat, we hope to find that problem and correct it. Okay, short demo on radio frequency interference. This is a rather inexpensive meter, can be purchased for less than 50 bucks. It measures RFI and EMI. We're going to try to show you the effect of shielding. So we're going to go over here where the cable is. Hopefully you can see the numbers. They're going to be hard to read. We're reading about 80 right now. As I move over the shielded, where I have tinfoil over it, you notice it goes almost to 0. There is 0. 0, 0, 0. Now we're going to come on out to the cable on the other side, and notice we went way back up again.